All right, good morning everybody. Hallelujah. 2020 is gone and done. 2021 is going to be much better. You guys are going to be back. We'll have a normal life. Track season is going to happen. Hallelujah. It's going to happen. Okay, here we go. Back to math. So I don't know how well we learned like right triangle trig last year because we were remote. But today we want to talk about trigonometry, okay? Trigonometry. The thing about trigonometry is trigonometry uses the ratios of sides in comparison to the angle. Ratios of sides to an angle, okay? And think about it just basically as an angle increases, the sides change, right? So there is definitely a ratio. Take a look. As the angle increases, so do the sides, right? And so all of those ratios with every angle and every possible side is all in the calculator, okay? So if we take a look at, first of all, I want to make sure everybody does this. If you're going to need a calculator. We've talked to that before, but before you do anything, make sure your mode, if you can find your mode, is in degree mode, okay? Now, if you're not in degree mode, if you're in radian mode, you're going to do every problem correctly but get wrong answers, okay? So before you do anything, try this. Try sine of 30, okay? Type that in, sine of 30, and see if you get 0.5, okay? If you don't get 0.5, you're in the wrong mode. So if I went to mode, I went to radian mode, right? Check it out, radian. And I went to the same thing, sine 30. I get the wrong answer. I don't want that. I want my mode in degree mode, okay? Not radians, degree, okay? Got it? Has to be in degree mode, okay? Now, if you have the correct mode, so let me write that up. Mode, your calculator must be in degree. Because when we talk about triangles, we're doing degrees, right? So before I do anything, let's talk about trigonometry. We're going to be doing right triangle trigonometry. So I'm going to draw a right triangle. Okay, so over here, I'm just going to draw any old right triangle. Okay, today it's a right triangle trig. We'll do any triangle later, but for right now, right triangle trig. And if it is a right triangle, if it really is a right triangle, then we better put a right angle in there. Okay, so here's my right angle. Okay, now one of the things we're going to see in our triangle, so we have a right triangle here, then we have two other angles here. So I'm going to use this symbol here, theta. Okay, see that symbol there? Okay, that symbol is our angle. Okay, when you see that symbol, it means angle. Now it is the Greek letter theta. But when you see that symbol, you want to think about angle, okay? So, here's a right triangle. Let's go ahead and talk about what we know. In a right triangle, the longest side, the side opposite the 90, is called the hypotenuse. If you were hanging out at the beach on this big triangular lake, and you threw a rock across to the opposite side, this is the opposite side. I learned this last year, okay? So this is the hypotenuse, it's the side, opposite 90. This is the opposite side because it's the opposite side of the angle. This is where you're standing. And then this side right here is called the adjacent side because it's next to you. So let's take a look at our ratios. So the sine of theta, and there's the abbreviation, is equal to the opposite side, so it's a ratio of the sides, it's equal to the opposite side over the hypotenuse. We learned this last year. Write that down, please, in your journal, in your notebook, somewhere, okay? The cosine, abbreviation is cos, cosine of an angle, it's a ratio of its adjacent side over its hypotenuse. So the cosine is equal to the adjacent side over the hypotenuse. Okay? The tangent. The tangent is the third ratio. We learned this last year. The abbreviation is tan of theta for the angle. And the tangent is equal to the opposite side over the adjacent. Okay? A ratio is just a fraction. Okay? Tangent theta is equal to the opposite side over the adjacent side. Now, these are new words, cosecant, secant, and cotangent. And they're the opposites of these three, the inverses. So these are the inverses. These are the inverses. The multiplicative inverse of these. So cosecant, believe it or not, does not go with cosine. I did not make this up. Cosecant is the opposite of sine. So cosecant, which is CSC of theta. I know you think cosecant goes with cosine. It doesn't. I did not make this up. I just teach this, okay? So cosecant, if it's the opposite of sine, it's going to be the hypotenuse over the opposite. It's just the reciprocal. That's all. Inverse, let's call it reciprocal instead. Okay? And the secant is going to be the reciprocal of cosine. So secant is SEC of theta. Secant then is going to be the reciprocal, which makes it the hypotenuse of the adjacent. And yes, cotangent does go with tangent. Now that makes sense, right? Cotangent does indeed go with tangent. So the cotangent is the reciprocal of tangent, so its abbreviation is COT, cotangent, but cotangent. It's the reciprocal, so it's going to be the adjacent over the opposite, okay? Those are our ratios. Ratios is a fancy word for fraction. Okay, now let's go ahead and take a look at triangle ABC. Okay, find all 6 ratios from angle B. So angle B is the angle I'm looking for. Let me call it theta, right? Because theta is my symbol for angle. Okay, so an angle B, right? So everything starts from your angle because then you get your names. So the 4 is my opposite side. My 3 is my adjacent side. Of course, 5 is the hypotenuse. So I'm going to actually write those in. Okay, so I want to put those in so I know that. I write these in on my notes. That from angle B is my opposite side because I threw a stone to the opposite side. This is my hypotenuse because it's opposite the 90. It's also the longest side. And then the 3 is my adjacent side because it's next to it. Okay, now let's do it. All 6 ratios. So the first ratios I'm looking at is sine, cosine, then tangent, cosecant, secant, and cotangent. So let's do that. So my sine, I want the sine of B, I want the cosine of B, and I want the tangent of B. Okay? I also want the cosecant of B, I want the secant of B, and I also want the cotangent of B, okay? So I'm just writing down the question. So it's all 6 ratios, okay? So I wrote them down of angle B. All right, so let's check this out. Sine then is the opposite of hypotenuse, so sine is going to be the opposite of hypotenuse, which is going to be 4 over 5. That's all I'm going to put for right now is 4 over 5. Cosine of B, let's see, cosine is going to be the adjacent of the hypotenuse, so cosine of B is going to be the adjacent of hypotenuse, or 3 over 5. That's my ratio. Tangent of B has got to be my opposite over adjacent, Okay, so tangent's opposite over adjacent. Opposite then is 4 over adjacent, which is 3, so it's 4 over 3. Now, this gets easy. If cosecant is the inverse, the reciprocal of sine, then cosecant of b is 5 over 4. Just flip the fraction. Just flip the fraction. It's reciprocal. Secant is just the reciprocal of cosine, so just flip the fraction. 5 over 3. And cotangent is just reciprocal tangent, which makes it 3 over 4. That's it. Now, those are the ratios. Let's actually do some math, because the ratios are just setting us up for doing some math. Okay, so let me flip this around. Let's take a look at it, okay? Example 2. Sine of theta is equal to 5/13. Find the other 5 trig ratios. What does this mean? Well, before I do anything, let's draw a right triangle, okay? Because it's really going to help me out if I draw a right triangle. Okay, so if I draw a right triangle, it can be anywhere, anyhow. So I'm going to draw a right triangle. Okay, so I'm going to draw my right triangle. Okay, draw a right triangle. It's really going to help a lot to draw a right triangle. Can I circle that? Draw a right triangle. Can I circle that? Can I highlight that? Draw a right triangle. I'm just going to, highlight that. To do this lesson, draw a right triangle, please. So now, theta. Okay, theta is an angle, so let's put theta in my picture. Okay, there's my theta. Now, what do I know about sine? Sine of an angle is equal to, well, let's check my notes out. Opposite or hypotenuse, okay? Sine is equal to, and I'll abbreviate, my opposite over my hypotenuse. Therefore, if I have sine is equal to 5 over 13, right? That's what my question says. Sine of theta is equal to 5 over 13. Then I know the hypotenuse has to be 13. So I'm going to put my 13 in my picture. Okay, so I'm going to put 13 right there. And my 5 has to be my opposite. So here's my angle. That's my opposite side. So I'm going to put my 5 right there. Okay, now what I don't know is the adjacent. Oh, but I know how to do Pythagoras theorem, don't I? Remember, a squared plus b squared equals c squared. Okay, so I do a little right triangle trig. I'm going to go a, b, c, right? So I'll go a squared plus 5 squared equals c squared, which is 13 squared. I'll do a little bit of right triangle trig here. I'm sorry, I'll do a little bit of Pythagoras theorem. So then I'll go a squared plus 25 equals 169, right? I'm just doing a little try. Pythagoras theorem minus 25, minus 25. A squared is equal to 144. Square root, and a is 12. Okay, so that's what I know that to be. That's my adjacent side. So I'm going to put my 12 in right here. Okay, 12. There's my 12. So 12 is my adjacent side, right? Write these so you can see in 12, 5, 13. Okay, so what I know is this. This is my angle. My opposite side is 5. My adjacent side is my 12. And my hypotenuse is 13. And then I'm just going to go ahead and do what I did before. I know sine. So I'll go cosine of theta. I'll do tangent of theta. I'll do secant. Well, I'll do cosecant first. I'll do cosecant of theta. I'll do secant of theta. And I'm going to go cotangent of theta, right? And I'm just going to use my notes, my ratios that we looked at before. Cosine, according to my notes, is adjacent to my hypotenuse, so it's going to be 12 over 13. That's my answer for my ratio. Tangent, opposite over adjacent, as my notes say, opposite over adjacent is going to be 5 over 12. Cosecant. Now it turned out that cosecant was the reciprocal of sine, and if sine is 5/13, then cosecant has to be 13 over 5. Secant, in our notes we learned that secant was the reciprocal of cosine. So if cosine is 12/13, then secant is 13 over 12. And cotangent was the reciprocal of tangent, so if tangent is 5/12, cotangent is 12/5. Okay? Now, example 3 is the same way, except for you're going to have some decimals, but we'll use square roots. Okay, and I'll let you guys work on that. Now, I'm going to shift up to example 4. Okay? It says, from this triangle, find all 6 trig ratios of 90 minus theta. Okay, so let's take a look at our triangle. I'm going to use this triangle up here. Okay? So let me redraw my triangle. Always draw a triangle. Always draw a right triangle. So I'm going to go ahead and draw it. Okay, I'm going to redraw this triangle. Here's my 90. Here's my theta. Here's my 12 and my 5 and my 13, right? That's what we came up with. Okay, that's the triangle I want to use right there. Now the 90 minus theta is this angle. Think about it. That's 60, that's 30, that's 80, that's 10. So I want to really use this angle, okay? So this is the angle I want to use, and I'm just going to use a different symbol. Let's use A for angle A. Okay, you guys are right with that? And we'll do the same 6 trig ratios, okay? So we'll do sine of A, cosine of A, tangent of A. We'll do cosecant of A, and angle A is this angle. We'll do secant of A, because A is that angle, and we'll do cotangent of A, which again is that angle. Okay, so then we'll do it this way. So it changes around. And now this is my opposite side, right? This is now my adjacent side. And this is now my hypotenuse. So things just switched around, okay? So sine, which is going to be opposite over hypotenuse, is going to be 12/13. Cosine, which is adjacent over hypotenuse, is going to be 5/13. Tangent, which is opposite over adjacent, is going to be 12/5. Cosecant, which is the reciprocal of sine, is going to be 13/12. Secant, which is the reciprocal of cosine, is 13/5. Cotangent, which is the reciprocal of tangent, is going to be 5/12. Okay, and that's all I have. We'll do more of this in Zoom, and we'll talk more about this in our lesson tomorrow.